Hi, I'm Christie Curry with National Grid, and I'll be giving you an overview of National Grid and the gas system today. So we'll just go through a brief introduction of myself. I'll give you a quick overview of National Grid US, a gas system overview, and then some of the gas departments and career path opportunities. So again, I'm Christie Curry. I'm a lead project manager with National Grid in the gas project development department for gas complex capital projects in upstate New York. I grew up in upstate New York, north of Plattsburgh. I then graduated with a Bachelor's of Science in 2010 from Clarkson University. My first role out of college was as an applications engineer with the Fulton Companies in Pulaski, New York. I then moved into a consulting role in the nuclear industry for about 7 years, working with commercial nuclear facilities as well as DOE sites. I then moved back to upstate New York and started my career with National Grid in my current role, and I've been here for about 3.5 years. So National Grid US, our purpose is to bring energy to life. We will continue to connect people to the energy they need for the lives they lead safely, reliably, and securely. Our vision is to be at the heart of a clean, fair, and affordable energy future. Our values are do the right thing, make it happen, and find a better way. So National Grid is a gas and electric utility that operates in New York, Massachusetts, and Rhode Island. And you can see on the infographics on the right side our service territories. So in New York, the green represents our electric-only service area, the orange is our gas-only service area, and then the blue is our combined electric and gas service territory. And then in Massachusetts and Rhode Island, the blue is our combined gas and electric, the teal color is gas-only, and the yellow is electric-only. So some key facts about our electric and gas infrastructure. And on the electric side, we have 377 transmission substations. We have 763 distribution stations and 8,900 miles of overhead lines. On the gas side, we have 94 take and gate stations, 433 gas transmission regulating stations, 1,287 gas distribution regulating stations, 1,184 miles of transmission pipeline, 35,654 miles of distribution main, and 31,081 miles of services. So an overview of our gas system. So natural gas is extracted by drilling into rock formations or shale. Fracking is the main technology that completes this. I'm sure we've all heard about fracking. The gas is then cleaned and transported through interstate pipelines. Along the way, there are gas storage fields and gas compressor pumps, which increase the pressure to help move the gas through the pipeline. So gas in the interstate pipelines could be anywhere from 200 to 1,500 PSI. And some of the main interstate pipelines that National Grid receives their gas from are Dominion, Tennessee, Iroquois, Empire, Algonquin, and Maritimes in Northeast. The gas then comes into our gate or take stations, and at these sites is where the ownership transitions to National Grid. This is also where the odorant mercaptan is added. So natural gas is naturally odorless, and that rotten egg smell that most people associate with natural gas is actually an additive. It then flows into our transmission pipelines, which is everything that operates at 124 PSI or higher. And off of those transmission pipelines, we supply electric generating stations. So they use the natural gas to produce electricity. And then also LNG plants, which liquefy the natural gas for storage, for future injection back into the system during times of high demand, such as during the winter months. From there, the gas flows to our gas transmission regulating stations, where pressure regulators reduce the pressure to below 124 PSI. And there are typically heaters at these sites. As pressure is reduced, the temperature also drops. So to prevent icing of our equipment, the gas is preheated prior to reducing the pressure. The gas then flows into our distribution system, which is made up of medium and low pressure gas mains and additional gas regulating stations, which will lower the pressure for local distribution, which is typically below 30 PSI. And that last step is our service main. which actually connects the distribution main to homes and businesses where it is metered before entering the home business for residential use. So one of the main aspects and important aspects of that entire system is the material. There are a variety of materials that have been used to make natural gas pipelines over the years, and the selection of those materials are based on a number of factors. So the date of installation, the diameter of the pipeline, the pressure requirements of the pipeline, and the overall characteristics of the local terrain. Cast iron is the oldest piping in the system. It was selected for its excellent resistance to corrosion. However, it's a very brittle material. Therefore, it's no longer being installed, and it's gradually being replaced or lined. Steel has been installed since the early 1900s. It was selected to replace cast iron as the material of choice in the 1950s due to being more flexible and stronger than the cast iron. However, it is susceptible to corrosion, so it requires coating and cathodic protection. And then finally, plastic. Over the past 30 years, it has become the standard for use in our distribution systems, which operate less than 100 psi. That's due to it being light and easy to handle, inert and impervious to corrosion, less costly to install, flexible and easily joined. So there's several methods for joining, one being mechanical couplings, next traditional fusing, and then lastly electrofusion, which we have a demonstration of for you today. So electrofusion is a method of joining plastic pipes using special fittings that have built-in electric heating elements, which are used to weld the joint together. So we have our demonstration set up here today. So electrofusion is a method of joining plastic pipes using special fittings that have built-in electric heating elements, which are used to weld the joint together. So we have everything all set up here already today. This large box is the electrofusion control unit, which does all of the work for us. And then we have our pipe set up here as well in this clamp. So we have our pipeline, which we'll be installing this T onto. So again, this is that special fitting. I have an example one here show you. There are those electric coils installed in the fitting itself. And then the pipe is prepared using this rotary peeler to ensure we have a clean surface to install the T. It actually scrapes off the top layer, a very thin top layer of the pipe to ensure there's no oxidation or contamination in the area which the T will be fused onto. So we will go ahead and get started. Like I said, the box does all the work for us. So we just turn the unit on. It goes through its internal self-test and calibration to ensure that it's working properly. And then it tells us connect the fitting. So we take our leads and we connect the red to red and the white to the white. It verifies what's there. It tells us to scan the barcode that comes with the fitting. Okay, so we scan the barcode, and then it will bring up all of the details, so the melt time and requirements. So what it's going to be doing is it'll actually, the electricity that'll flow into the fitting is prescribed based on the barcode that's scanned. And then it'll actually, the coils that'll in here will melt the surface of the fitting. And then as that melts and the heat is continued to be applied, the pipe surface melts itself also. And then those two melt pools come together to perform the fusion. Just make sure I capture everything. So ensuring the good mix of the fitting melt and the pipe melt, ensure that you have a sufficient weld. And then we listen to the box and it tells us the prescribed cooling time to ensure that that weld is complete. And we have a couple of examples here today. So this is just a cutaway piece, and you can actually see those coils that are in there and then how it was fused together. And then this is another coupling piece where you can see the two ends of the pipeline, and then this was the coupling fitting over the top. And again, you can see those coil pieces in there and how they all fused and welded together. And then this is what we installed today, is a T on the pipeline. And then the test that they do on this after is they actually put it in a clamp, and the two sides of the plastic are squeezed together so that they're touching, and then they verify that those welds were sufficient on either side. So where do we go from here, and how does all of this fit into National Grid's commitment to the cleaner energy future? So there's actually several initiatives that National Grid is working on for the future of heat. The first is demand response. So we encourage customers to use gas at off-peak times, which reduces those peak loads. If you're a National Grid customer, you probably received communications this past summer during some of those heat waves in August about reducing some of your usage at those peak times. Next are smart grid metering technologies. We have programs underway to change out traditional meters with smart grid meters, which allow for real-time monitoring and usage of gas at a customer's premise. And that also provides additional safety functionality as well for excess flow and overpressure protection. And then we have two initiatives that will allow us to utilize our current gas system and infrastructure, but decarbonize the medium. The first one is renewable natural gas, which is any pipeline compatible gas that comes from a renewable source. So typical sources are your farms and animal manure, or landfills and waste treatment plants. So those emissions are captured and then cleaned and treated before being injected into the gas system for usage at our customers' premises. And the second is hydrogen blending, which is a process that uses renewable electricity, typically from wind or solar power, to split water into hydrogen and oxygen. The hydrogen can then be introduced with methane into our system, and it reduces our greenhouse gas emissions. And then lastly, what are some of the departments or career paths that are associated with all of this? First and foremost, National Grid is an inclusive and equitable company. So we're committed to building an inclusive company where everyone can achieve their potential. And we continually seek to diversify our workforce. So some opportunities are engineering and asset management. So there are engineering groups associated with each of those assets that we discussed earlier in the gas system overview. They typically work on the existing infrastructure and ensuring its integrity. But they also work on projects for replacements, upgrades, and specifying new installations. And then there are also opportunities in the operations side of the house, which is in the field and a little more on hands-on work, again, on all of those assets that we talked about earlier in the system overview. And so again, just a sample of the opportunities here at National Grid, and we hope that you're interested in what we do and where our future will take us. Thank you.